Now, when finding the equation of a straight line, there are two things that we really need. That's a point and a gradient. As long as we have a point and a gradient, we can find the equation of a straight line, regardless of which method we wish to use. We could use the gradient intercept form, this equation here, which we looked at yesterday, or we can use this formula, the point gradient formula, which is, rather than this one, which requires you putting some things in, substituting, solving and getting back and then writing the equation, this merely requires you putting in the point, putting in the gradient, and then doing the algebra to simplify it and to get it into whichever form you so wish to have it in. So, for example, a straightforward question might have a gradient of 1/2 passing through the points, or the point 7, 9. So it is really just a matter of starting with that equation, substitute the points in and the gradient. So x and y are our general x and y values, so to speak. We do not substitute in for those, but we do substitute in for y1. The y value of the point is 9. The gradient is 1/2. X minus the x value, x1, is 7. So that really is our equation of the line. It's not in one of the accepted forms, so we then have to decide what do we want to do. To get it into the general form, if there's a fraction, I find it best to just multiply both sides by 2. So that gives me 2y minus 18. That 2 cancels out with that 2. And we get x minus 7. And then we swap the things onto the right side. We want to get a positive x, so I'll move everything from the left to the right. Got to take away 2y. Got to add 18. So negative 7 plus 18 turns out to be positive 11. So there's my equation in the general form. If I was looking to get it into the gradient intercept form, then when I get to this line, instead of multiplying by this fraction, I simply expand it. So that gives me x over 2 minus 7 over 2. Add 9 both sides. X over 2, negative 7 over 2 plus 9 is 18 minus 7, 11 over 2. Okay, so plus 11 over 2.